Good morning. Welcome back. So, last class we did linked list. We started with linked list. I just gave you an introduction like how a list would be and what is a node and what are the different parts of a node, like the two parts of a node in case of a single linked list. Here we are talking about single linked list, not even the single circular linked list, and how the data is stored, what is the structure, and how do you declare the structure, and then how do you take in data. I also showed you small code wherein I dynamically allocated memory, and how do you take in the data and store it in the information part, and how do you make the link part null. So that is basically a node, and then the operations will be doing on linked list are traversal. Yes, I told you what is traversal, that is visiting each node exactly once is traversal. At the end, maybe I'll show you one program of traversal, but then and in your syllabus you have creation of linked lists, then insertion of a node in the beginning of the list, end of the list, and at a given location. Same way, the deletion of a node in the beginning, end, or at a given location. These are the things what is there in your syllabus. So I would be starting with the algorithm to create a linked list. How do you create a linked list? So please note down the statement of the algorithm. Once I write the algorithm, I'll explain you also. And then we will do the insertion part. Like, yes, before that I will show you one program wherein I would be creating a linked list, and then I will print you the contents of the list. Maybe that will be traversal, because contents means to take out the processes to extract the information part and print it on the screen. That's a process, and exactly once I would be visiting each node over there, so that we can do. So before that, I want you to please write down the statement of the program. Algorithm to create a linked list. Let list be a linked list in memory. This algorithm creates a list. The pointer head points to the first node of the list. So head is a pointer which points to the first node, and current PTR, CURR PTR, current pointer points to the node currently being processed. Main thing is I use current pointer for traversing the list. Either I can use it for searching for an element in the list, or to create a linked list wherein I need to traverse till the last node in the list and attach the node over there, because I need to create a linked list. Getting it? Now there is no list available, so I would be creating a new list. How do I do that? That is the algorithm. When I say insertion of a node in the beginning, end, or at a given location, it means that a list is already there, and to the already existing list I am going to add a new node. But here the list is not there, I am creating a new list. Getting the difference between the two. I am adding or inserting happens to an already existing list. Here I am going to create a linked list, and in that there are two pointers which would be pointing to the node. So the data type would be node only. Yesterday I showed you that. Before that, when I do programming, I will declare the structure of the node and the pointer and everything. But here in the algorithm you give the logic how to accomplish a task in a finite number of steps. You don't have to write code for each, it's just the logic. Coding we will do when we do program. So now hopefully I've written down, just note it down soon. We'll start with the algorithm. So step 1. What is step 1? Initialize the head. Yes. Why do I need? Why do I need to initialize the head? Because to begin with, in an empty list, the head, that is the pointer pointing to the first node. Head is a pointer which points to the first node. From that is how I know which is the first node in the list, and then the link part of the last node points to null in a single link list. So that is how I will know which is the last node and which is the first node. And how do I know the second, third, fourth and fifth? Because from the first node that would be pointing to the second node, and then the reverse is not true. Like second cannot point to first. First only the direction of traversal will be only in the forward direction starting from the first to the last node, because the first node has the address of the second will have the address of the third, fourth and fifth, so on. But I will not have the address of the previous node here in a single link list, and this is not even circular, so I cannot entirely traverse. In circular linked list, what happens, you don't have, you cannot go back, but then you can traverse, take a full round and come back to the same position. That is possible, but in a single linked list, after the last node you cannot go back to the first node because it would be pointing to the null. Getting it? So the each node will be pointing to the next node in the list. That's all. It will not know about how many nodes are there and what are they. It will only have the information, or it will have the link part would be pointing to the next node in the list. And how do I have a first node? The first node head is a pointer which would point to the first node in the list. So initialize head. What should I initialize to? To begin with, when there are no nodes for an empty list, when there are no nodes in my list, head should be null. So if head is null, that is how I find out, right? If head is null, then it is the first node in the list. Whatever node I create, that would be the first node if head is null. Otherwise, already there are nodes in my list. Step 2. What will I do in step 2? Then after making head is equal to null, I need to create a new node and store it in the like I store the address of it in a pointer called new node. Correct? Yesterday also I did it dynamically. First I created a pointer, declared a pointer new node, and then during using dynamic allocation, I just allocated memory for that node, new node dynamically, and then it is assigned to the pointer new node. So create a new node and store its address in the pointer So the name of the pointer is new node. I will be storing the address of the so create a new node and store its address in the new node. Okay, like create a new node and store its address in the new node. Here I am talking about creating a new node and storing its address in the new node. New node is a pointer and new node are two words. Like I'll create a new node in which I can store data, each that is different than this new node. New node is a pointer which points to this node. Getting it? Hopefully don't get confused. Then what should I be doing? How do I do that? Please make a note of this. along with me. So new node, this is different than the address of new node. So what am I doing? I'm dynamically creating a node and storing the address of it in the pointer. Like I'm making the pointer new node point to the address of the new node what I have created. After that, what will I be doing? Copy the information of the new node in the information part. Yesterday also I asked the user to enter the information or the data which has to be stored in the information part. Now also you have to do that. Step 3, copy the information for the new node in the information part. How do I do that? I can do that because info of new node is equal to value. That is, I declare it as ELE. You can have info is nothing but the variable name. So info of info of new node is equal to value, and then what you have to do, you have to set the contents of the link part to none, right? Step 4, so I need to set the contents of the new link part to null. How do I say? Link of new node, right? Because first I'll create the new node, then I will make the ask the user to enter the information part, take in the information part, and after that I need to make the link part of the new node to null. After that I'll worry about whether it is the first node or whether there are nodes in the list, so that if there are nodes in the list I need to traverse the list, and then I need to attach the new node to the list. If it is the first node, just make head point to new node and exit. These are the things what I am going to do. Before that, first when I create a new node, before it is going to be attached or anywhere linked to the list, I need to first take in the information part. That would be taken part, and that would be taken from the user and stored in the variable which you would have declared in the structure. After that, what you will do, you will make the link part of the node point to null. Then only I will see whether it's a first node or it is not the first node. If it is not the first node, then I will traverse the list and until I reach the end of the list, and then make the last node point to the new node so that it gets attached, right? So next step, step 5. So what I should do in step 5? In step 5, I should check is the new node the first node. How do I check it? If head is null, the new node is the first node, because head is a pointer which points to the first node in the list. Is the new node the first node? Yeah, how do I check it? I have to check if head is equal to null. Yeah, and if yes, what I have to do? If it is correct, then if yes, what I have to do? The answer is yes. Then if it is a new node is the first node, then what I have to do? I have to connect the new node to the header. How do I do that? I will just make, instead of head is pointing to null, instead of pointing to null, it will point to the new node, whatever I have created, right? Head is equal to else. If it is not the first node, then what I should be doing? That is what. Like first, is this the first node? If the new node is the first node, head would be pointing to null. So if head is pointing to null, then it is very easy. Make head point to the new node, because always the first node in the list is identified by head, because head is a pointer which would be pointing to the first node in the list. If it is not the first node, that is, if already there are nodes existing, what will I do? It will go to the else part. Yes, it should go to the else part only. In the else part, take the current pointer to the last node of the list. Yes? How do you do that? Make the current pointer first assigned to the first node, that is head, and then go on traversing. Current pointer is equal to link of current pointer. Link of the node would be pointing to the next node. So when you say link of current pointer, whatever is the link of that current node to which the current pointer is pointing to, it will go to the next node. Take you write it down. I will tell you how it works. Okay, and that I have first. What is that? Assign the head to current pointer. Why? Because you have to start from the first node, right? So because when you are traversing, you have to start from the first node to the last node. So first step I will do is to assign the head to the current pointer. How do you do that? Current pointer is equal to head. So head is pointing to the first node. Now current pointer will also be pointing to the first node. Getting it? Then after that, while the link of the current pointer is not null. Why? Because while the link of the current pointer is not null.
If it is equal to null, it means it is the last node. Until the current pointer's link is not null, it means that there are still nodes in the list. Getting it? Move the pointer to the next node. How will I move the current pointer to the next node? Just by assigning is equal to link of current pointer. Link would be pointing to the next node. I will show you also how it works. Please don't get confused. End of while. So now next is connect the new node. Once I go to the end of the last node, then I need to connect it to the new node. That is, the last node should point to the new node because that would be the next node in the list, right? And then new node anyway link part is pointing to null, so you don't have to worry. Connect the new node to the link of the last node. How do I do that? Link of current pointer is equal to new node, right? Then exit. And then what is the step number? Step 5 is done. I will just return. Step 6 is return. Okay, let us go back here. I will go through this again and then I will take that example and show you how it works. So first what I have to do, I have to, in an empty list, head is a pointer which points to the first node in the list. So I will make head is equal to null. So that one why I am doing, because there are no nodes in the list. After that I will create a new node. What is the pointer? This one, NEWNODE as a word is the new node. New space node is different than the new node. So this new node is what is a pointer which would be pointing to the new node what you are creating. So address of the new node. Each node in a list is nothing but each element is stored in a node. Okay. So list is a collection of nodes. So each node, that capital NOD is a node, and new node is a pointer which points to the new node when you dynamically create it. Getting it? After that, what you do, you ask the user to enter the information part. I take in the information part and then I have to set the link part to null. So what I did, head I to begin with, I know that there are no nodes in the list, so I will make it as null because head will point to some node if the linked list is not empty. After that, dynamically I created a node, and what did the new node is a pointer which would point to the dynamically created node. After that, I'll ask the user to enter the information part, and I will take in the information part, and then I am making the link part to null. This one is not connected to the list in any way. After that, I need to connect it to the list, right? So how do I do that? There are three conditions, like there are two conditions. First, you have to check whether this is the first node or not, and then else part is it is not the first node. So I need to traverse the list. If there are 5 nodes, then I need to go to the fifth node, and then I need to connect the fifth node to the newly created node. Yes, that procedure is simple. Like if it is the first node, then I need to make head, instead of pointing to null, head should point to the new node, because first node in the list, head would be a pointer to the first node in the list. That is what is the new node first node. How will I know? If head is equal to null, the new node would be the first node. If yes, then make it point to head. That is, head is equal to new node. So head would be pointing to the new node. Else, if it is not the first node, what I need to do? I need to use a pointer called current pointer, which will CURR which will point to the last node in the existing list, so that once it reaches the last node, the link part of that, instead of pointing to null, should point to the newly created node, so that it gets attached. Yes. So take the current pointer to the last node. How will I do that? Current pointer is equal to head. It will first point to the head part. After that, I will say link of current pointer. Current pointer is equal to the link of current pointer. So link of current pointer would be pointing to the next node in the list. So it will go on moving until the current pointer's link is not null. Why? Because when you reach the last node, the link part of the last node would be null. That is why I will do that. This is the traversal operation. CURR, it is not CIRR. So after that, end of the while. While the link of current pointer is not equal to null, move the current pointer to the next. Then make the link. Once you go to the last node, it will go out of the while, because the link of the current pointer would have become null, because the last node's link would be null. Make it point to the new node and exit. So now we will take this in the example over here. What I did here, I created a node. I will make the information part. I will write some number. See, for example, I can say I want to enter. I entered 256, and I am making link part to null. This is my newly created node. I created a name of that is new node. So the name of this is new node, that is new node, and then this is a node in the list. And then nothing is pointing here. 256 I added, and link part I made it null. Okay. Then you have to check whether this is the first node in the list or not. How will I check? When head is null. Here head is null. So what I will do? I will just make head point to this, and the link part is null, because this is the only node in the list. That is why it is the first node as well as the last node. Till here, hope no doubts. That is, since this is the first node and the last node in the list, the link is null, and then head is pointing to this, and I have stored the information part, and link part is pointing to null. After that, I will create a new node. I created one more node. Okay, is these two connected in any way? They are not connected in any way. That is, I need to attach this to this part. Instead of this node pointing to null, it should point here. Correct? Until this one is null is correct only because the link part of the last node will point to null. This would be the first node. This would be the second node in the list when I create it again. So I stored what? 156 over 165 in the information part, and I made the link part to null. Then is head null? No, head is not null because head is already pointing here. So it is not pointing to null. Getting it? So this is not the first node. Then I need to traverse. That is, I need to traverse the list so that it goes to the last node, and then I need to point this here. How do I do that? Current pointer is equal to head, right? So I will say current pointer is equal to head. Head is also pointing here. Current pointer also is pointing here. While the link of the current pointer is not null. So yeah, here when it is pointing here, it is definitely not pointing to null because it is pointing to this node. So it will go inside. Current pointer is equal to link of current pointer. Current pointer is equal to the link of current pointer, which is null here. Correct? Yeah. And then next time when it goes, it will go out of the while because yeah, link of current pointer is equal to null. So it would be here. Link of the current pointer instead of this null is equal to the new node. So here I will make it point to the new node. So current pointer is here now because it is pointing to the new node. Link of the current pointer was pointing to this, which was pointing to null. Then I came out of the while because I traverse it only till the link of current pointer is not null. So then it is joined here in the list, and this is the last node. That is why the link is pointing to null. First node link is pointing to the next node in the list. Head is pointing over here. After this, I will create one more node. So 550 I stored, link part I made it to null. Getting it? Every time create new node only will be the name of it. And then I have to check whether this is the first node in the list or not. No, it is not there because two nodes are already there in my list. If head is not null, so I will make the current pointer point to head. So it is also pointing here, while the link of the current pointer is not equal to null. I need to traverse it. Current pointer is equal to link of current pointer. I will go on assigning that until the link of the current pointer is not null. To begin with, inside the while loop, while going inside, yes, it is pointing to the first node. The link part of this is not null. So it will go inside, and then current pointer is equal to link of current pointer. So what is the link of current pointer pointing to? It is pointing here. Then it will go back and then check. Definitely it is not pointing to null, right? Then it will come here. Current pointer is equal to the link of current pointer. It is pointing to null here. It will go back. It will come out of the while, and then what it will do? You have current pointer link is equal to new node. Current pointer link here is equal to new node. It got connected here. This is how it works. So hopefully you have understood the traversal part, and you would have made a note of the algorithm, because algorithm, this is the explanation of the algorithm. Please make a note of it if you have not made. Then I will show you the execution of the program, that is creation of a linked list. We'll write a program to create a linked list. We'll add nodes, both the information part as well as the link part. I will set it like information part and then make the link part. We'll add nodes, and then I will print you the data in the information part. Fine. Before execution, let us do the program first. So write a program to create a linked list. So first, what will I have? I will have my hash include statements. Hash include iostream dot h hash include conivo.h hash ctype.h. Okay, hash include iostream.h, conivo.h, and ctype.h. These are the three header files I'm going to have in my program. After that, let me start with my class linked list. Let me name it. Let the name of my class be that, and in the private section, private, public and protected are access specifiers, but since I will not be doing any inheritance here, I will be writing only the private and the public, wherein private is not accessible outside, whereas public can be accessed anywhere from outside. Private data can be accessed only by the member functions of the class. So if you don't specify anything, by default also it is private. So private, let me have the structure of the node. So struct node. Let me have in the information part. What will I have in my information part? Let me have int ele element in the information, as well as I will have a link, which is a pointer which would point to another node. So it is going to point to another node. That is why it is the data type is struct node link. This completes my structure. Fine. After that, struct, let me say star head is a pointer which points to the first node in the list. For that reason, I will be using it here. Head is not a keyword, but according to this program, head is you can have start, first pointer, whatever. But make sure if you whatever name you give, follow the same thing, and that should point to the first node in the list. So this is my data members, and now let me start with my member function. So I will be writing it in the public section of the class. I will be starting with my constructor. Why do I need a constructor? Because I need to initialize the value of head to null, because there are no elements in the list. Like there are no, not elements, I can say there are no nodes in the list. It's an empty linked list. So for that reason, to begin with, head would be null. Constructor is a special function which is written in the public section of the class, which do not have a return type, and it has the same name as the class name. So next is void create, and let me pass an integer argument. That is the information part I will pass from the calling function. Fine. Void print will print the elements of my list, and this completes my class. So I do have a constructor, a function, and then print will print the elements of the list. This is my class linked list. Now let me start writing the code for the member functions, or let me define. I have declared the member functions in the public section of the class. Now I need to define it. I'll start with linked list. Since there is no return type, I will start with the name of the class to which it belongs to. What am I making here? Head is equal to head should be equal to null. To begin with, when there are no nodes in my list, head will be null. Check for the spellings. Okay. In the public section, void create. Next is create. And it is going to take one parameter. The return type of function create void name of the class to which it belongs to is linked list. Scope resolution operator create int num. Let num be the formal parameter. So now first what I have to do, first create a node dynamically, that is create a node. Okay, how will I do that? First I need to have struct node, new node. Let it has to be a pointer. Okay, star new node, struct node star new node. After that new node is equal to, new is the operator for dynamically allocating memory during runtime. New of node, which will allocate memory dynamically during runtime. After that, I need to store the information part of the node, right? So it will be new node. Information part is what? ELE. I have declared it as ELE here. So you can see here ELE I have declared. I have declared the nodes information part is int ELE, which is the variable. So in that I need to store the data. So I will say new node of ELE is equal to num, because I am passing it. So whatever is the num value should be stored in the information part of my node, and then the link part of the node is going to point to null, right? That is what I am doing. Like I have created in this, I dynamically created a node. Okay, that is first I declared, then a new of node. This will create a new node, dynamic creation of the node, then new node of information part, that is ELE I had declared. ELE is equal to num, which is I'm passing from the main, because from the calling function, and then the link part I made it to null. After this, what should I do? I should check whether this is the first node or not. How will I do that? If head is null, it means that it is the first node in the list. So is equal to new node over. That's all. And that is, if you want, you can write cout. This is the first node in the list. You can write, or you need not. It is up to you. That doesn't matter actually. So now head is not pointing to null after this. Head is pointing to new node, which is here. I have created it. I have stored in the data, that is the information part. I made the link part null and checked whether this is the first node or not. And then since if head is null, it means that it is the first node. So I will make it point to the new node, because head points to the first node in the list. Else, if it is not true, already there are elements in my list, what should I do? I should traverse the list till I reach the end of the list. So struct node star current pointer is equal to head. That is, it is going to, I have created a pointer of the same type, node type, and then I'm making that current pointer point to head. That is declaration and initialization in one step. I'm not using ampersand because both are pointers. After that, until the link part of the current pointer is not null, because once it becomes null, it means that we have reached the last node. Only the link part of the last node would be null in a single linked list. So I will put it while pointer link is not equal to, this is a symbol which you will be using to write not equal to, right? Which is not equal to, sorry, which is not equal to null. Until the link of the current pointer is not equal to null, you go on incrementing or traversing or moving the current pointer from one node to another. Current pointer is equal to current pointer's link. Where will the link point to? The next node. So it will go on doing it until the last node is encountered. After that, once the last node is encountered, you need to make the current pointer's link point to the new node. Okay. So this thing is done. After this, end. It's like done. Node gets inserted, and then current pointer I traversed, made it. Then this is the end of my create function also. In create, what did I do? First I declared a new node, then new node is equal to new of node, which will allocate that many bytes of memory to this during runtime, and then the information part or the data part I stored it, then made the link part null, checked whether it's the first node in the list. How do I do that? Using head is double equal to null. If head is null, it means that it is the first node in the list. Head is equal to new node. Otherwise, traverse the list using the current pointer. Here what I did, I declared current pointer, which is of the type node, again a pointer, and assigning a declaration and initialization. I am making it point to head. Since head is also a pointer, current pointer is also a pointer, you don't need an ampersand over here. After that, you will go on traversing until the link of the current pointer is not null. See, current pointer now is pointing to the first node, because current pointer is equal to head I have done here. So current pointer's link is not equal to null. Only the link of the last node is equal to null. So till that time it will go on traversing, and then once it comes out, I will make the link of the current pointer point to the new node, and that is the end of my create function. After that, I need to write my print void linked list print. So what will it print me? See out the list contents. So how will I say? Before that, let me say one more thing. Struct node, let me create one more pointer. ptr is equal to head. That is, let it point to the first node in the list. while ptr is not equal to null. Fine. So how will you do that? If ptr not equal to null, it points to null only when it reaches the last one, last node. What am I going to do? If ptr is not equal to null, see out. What do you have to print? You have to print the data part of it. So I will say information part of the list. Information part of the list and ptr ele. So this is the information part of the list ptr ele element. That is what it is stored. And now ptr is equal to ptr link. So it will point to the next. Before that, I can say here my while is done. I have to just come out and then my function also would be done. Okay, list contents, my function also is done. This completes the definition of all the functions of the class. Like first what did I do? I declared private struct node. So in that I have int ele, two elements like int ele and struct node star link. Star link would be pointing to the node. So it is the self-addressing pointer of the type same structure. So struct node star head is also another pointer which would be pointing to node. In the public section I have three functions. One is a constructor and two functions. In the create, here I am making head is equal to null because in an empty list head is null. So void linked list create int num. I am passing number as an argument, an integer argument to it. Then struct node star new node. I am creating a again new node which is also of type pointer, new node which is also of type node, and then using new I am dynamically allocating memory for the structure node and then that is assigned to new node. Then I am assigning the value that is for the information part of the node. Whatever I am passing from the calling function is assigned and link part I am making it as null. Then I am checking if head is null, that is the first node, so I will make head point to new node. Else I should have one more pointer I am having called current pointer and I am making it point to head until the link of the current pointer is not equal to null, because the link part is null means that is the last node of the list, that is we have arrived at the end of the list. So you go on current pointer is equal to current pointer link, it go on traversing from first node to the last node, and once you come out of it you make the link part instead of pointing to null point to the new node. In the print, the same way you go on printing from the first node the information part, that is ele you print and then increment using the pointer is equal to pointer link. This is the end of the functions. So void main. Void main, what will I write? Clear screen, then int num char ch is equal to y. After that, while ch double equal to y, I will say C out, enter the information part of the node. I'm asking the user to enter the information part of the node. C in, what is there? Num, right? After that, I need to call the function. For that, I need to create an object. So, linked list lobj. So, I will say lobj dot create, and I'm passing num as an argument to it. Do you after this see out, do you want to add one more node? Yes, no, enter C in ch. ch is equal to lower ch. Okay, this is the end of my while, that is see out the information part of the node, C in num, and then I call the function create and pass num as an argument. Do you want to continue? If the user wants to, then it will go back again, ask the user to enter the information part of the node, take in and go on creating. Once you say no, it will come out dot. I will be calling this function wherein the contents of the node would be printed, and then what am I going to do? Get ch end of my main. Hopefully you have understood this. You can have a look. Again, while executing also, I will explain it again. But this is not very difficult. It's easy only if you can. This is just a node creation. I have created it, and then I have called the print function. So it is done. Stay safe, take care, and then all the best for your test. Do well. See you on Monday. Bye bye.